Okay, in this video, we're going to go ahead and look at linear and absolute value inequalities. I see this first example, and I know it's an inequality because it has a less than sign. Then how do I know that it's linear? The reason I know it's linear is because the x is only in the numerator. Okay, if it was in the denominator, then we would be having a rational. But it's linear because x is only in the numerator, so if you look here, and also is only x to the first degree. Okay, so whenever you have a linear equation, that means there's just x's and they're only in the numerator. Your goal is to get all your x's by themselves. Okay, so get x by, by themselves on one side and the numbers, any other numbers on the other side. This one requires a little bit of work. We have a fraction, okay, then this one, you can write it as a fraction, it's over 1, and then we have another fraction. So our first goal is going to be able to get a common denominator. So I look at all my denominators, okay? I have 4, 1, and 3. My least common denominator between the numbers 4, 1, and 3 is 12. So I'm going to go ahead and do that. I'm going to make everybody have a denominator of 12. So in order to make the 4 12, I would multiply the top and the bottom by 3. This one, to make 12, I would times it by 12 here. And then to make this 12, I would multiply by 4. Ooh, that looks like a 9. 4. There we go. All right, so what I will now have is 3x minus 3 all over 12 minus 6 times 12, 72 over 12 less than or equal to 4 times 2x plus 1 all over 12. Okay. This left-hand side, since it has a common denominator, I'm going to go ahead and write that together. So I'd have 3x minus 3 minus 72 all over 12 less than or equal to 4 2x plus 1 all over 12. Okay. So now this is nice because if I were to multiply both sides by 12, my denominators will be gone. Okay, so whenever you have fractions, your goal is to get a common denominator, and then you can multiply both sides by it, and the denominators will cancel out. So those will cancel. Then we would have 3x minus 9 minus 72 less than or equal to, distributing here, 8x plus 4. And as you guys can see, now we're back to a nice linear equation that looks more familiar to you. And so I'm going to go ahead and get all my x's to one side. I like to keep my x's positive if I can. You don't have to. So I'm going to move my 3x to the right-hand side. So I'm going to subtract 3x from both sides. And if I combine negative 9 minus 72, I will have negative 81. Less than or equal to, this is 5x plus 4. And I'm just trying to get x by itself. So subtract 4. So I got negative 85 is less than or equal to 5x. And then if I divide by 5, I will have x over here greater than or equal to, negative 85 divided by 5 is 17, negative 17. All right, so we got to make sure we put our answer in boundary notation. Okay, so if I want to have this in boundary notation, I'm actually going to write the x first. So I'm just going to flip it. So I got x, and then see how this is the greater than sign. So it's x is greater than or equal to negative 17. So my final answer then, will I have it going towards positive or negative infinity? If x is greater than or equal to negative 17. It's going to greater to positive, so I would have negative 17, comma, infinity. This will be a bracket, and then it can't be infinity, so it's parenthesis. Okay. So there is that. Another thing that we should remember or recall, when we solve inequalities, if you ever divide or multiply by a negative, remember when you're at this step right here, if you divide or multiply by a negative, you need to flip the inequality sign, so don't forget about that. Okay. So here is our linear equation. Something I would point out is on your homework, they're not all going to be this complex. They might be simpler, more like they'll start out like this. So if you notice it's linear, everybody has an x to the first power. You just have to go ahead and get x by itself. Okay, that's your goal. The other example we're going to go ahead and look at in this video is the absolute value. How many answers are there with an absolute value? Do you remember from last year? There are 2. But yes, here's our good old absolute value. And if I read this, this is a greater than sign. Greater. So it's an or statement. Okay. Another thing you should probably remember, if you have a less than or less than or equal to, this is a less than, so it's an and statement. Okay. So there's or and if you guys remember when you graph or statements, typically you got arrows going the opposite direction. And then if you graph an and statement, they're typically shaded in between. Okay, so kind of something to pay attention to. But the biggest thing is there are 2 answers. Okay, so let's go ahead and set up how you do this. Whenever you have an absolute value, your goal is to get your absolute value all by itself. Okay, so this one's perfect. It's already there by itself. If we were to have 2x minus 6 plus 5 is greater than or equal to 23, the first thing you would need to do is get the absolute value by itself. So now we have 2x minus 6, 18. Okay. Now from here, you would be fine to find your 2 answers, but you just have to make sure you get your absolute value by itself, so don't forget that step. Okay, so here I have done that. I have my absolute value by itself. So what I can do is I rewrite what's in the absolute value exactly as is, and then you say greater than or equal to 18. Okay, this is a greater, or my other answer is 2x minus 6, and then we flip the inequality and we make it negative 18. And then we need to solve both of them. Okay, so we would, to get x by itself, add 6, and then divide both sides by 2. So x is greater than 12. That's the first part of my answer. Okay, the next part of my answer is solving this inequality. I have 2x is less than negative 12, and then if I divide both sides by 2, I'm dividing by a positive 2, so it's going to stay. Don't flip the sign. This is negative 6. So here are my 2 solutions. So if I were to graph it, hardest part, you guys, sometimes is putting the numbers on the number line. Always do a smaller number to the left of the right. It's a silly mistake, but it happens. We got negative 6 and 12. And then we are not equal to, but x is less than negative 6, so going to the left. Or x is greater than 12, so open circle at 12 and going to the right. So there's our or example. And then there's more than one inequality, so we're going to have to combine, or going to have to write it combined with that compound inequality, so it'll have a union in it. So the way we write this one out in interval notation, we're going to the left. So I got negative infinity, comma, negative 6. It's not included, not equal to, so parenthesis, union, parenthesis, once again, 12 is not included, 12 to infinity. And that is our absolute value inequality.